There we go. All right. I'm having issues. I forgot how to work this stuff. So anyway, here we are. Sorry, it's kind of so velocity, object of one speed. There we go. We figured that out. Now here's Usain Bolt. Now this is an interesting thing. Um, it's now this is in 2010. It's talking about last year. Bolt stunned the athletics fans when he hacked 0.11 second. I mean, 0.11 seconds. That's like that's like almost scoring 100 points in a football game, in an NFL football game. To beat somebody that bad, or to beat somebody in an NFL game by 70 points. It's just unheard of. Intrigued, was he at the ultimate human speed? And so, Mark Denny at Stanford University, he's an engineer, I think, and he examined previous records for athletes, greyhound horse races for good measure since the 19th, and found that performances in many events followed a similar pattern, improving steadily until they reached plateau. Horses in the Kentucky Derby, for example, appeared to reach their speed limit in 1949. Since then, any improvements have become minimal and increasingly rare. Then there was, of course, Secretariat, who was unbelievable. But anyway, it's outlier, an anomaly. Human athletes, too, seem to follow this pattern. Timings for the women's 100 meters approached a plateau in 1977. Started taking a little steroids, got a little bit faster, started getting off the steroids. It's gone back down to where it's supposed to be. Because if you notice all these world records in the mid 80s and stuff, it's like, yeah, right. Anyway, Denny says they seem to on the verge of topping out. He predicts an absolute limit of about 9.48 for the 100 meters, just 0.1 seconds under Bolt's current record. If he keeps on course, he will soon come close to the absolute limit. Yeah, and it's because what gives this rise is because it's as simple as the athlete's power to weight ratio. Beyond a certain point, the benefits of stronger muscles, which are very heavy, and longer limbs, which are much more heavy, will be offset by the increased energy required to shift the greater load. Okay, so eventually it's just, put too much power on that, mini bike. You put 1,000 cc Harley motor on a mini bike, it's not going to go anywhere because the motor's too big. All right, so there's that. All right, and male speed versus distance. Now notice the speed is really, really fast when the distance is really, really small. You get up to a marathon, and then the speed is really, really low. Okay, and that's just because you cannot sustain that run for that long. All right. In fact, we accelerate. And when they run it, and we'll look at this later, they run the 100-meter dash, they are slowing down. Actually, they have this huge acceleration of almost 1G at the beginning, and then they slow down throughout the race. And it's whoever can slow down the least wins. All right. Well, anyway, that's where we're going to end the slides, and then we'll start talking about the field of vision and stuff like that in the next unit. So let's just look at the homework. All right, I think we can do that now without much trouble and get through this. No, as a matter of fact, I'm going to stop this right here.